Thanks, Esben, and thanks for the Alignment Gem infrastructure with recordings and everything. Yeah. So hi everyone. Thanks for joining. This talk will basically be about a safety infrastructure, and I'll go over what exactly do I mean by that, why we're particularly excited about this flavor of research at Stromly, and also what are some opportunities that you could explore during this hackathon and also afterwards. Um, so the basic idea is that AI has both huge potential upsides and huge potential downsides. And unfortunately, capturing the benefits while mitigating risk is tricky. So on one hand, you've um, got people advocating for like radical open source and granting everybody access to the latest capabilities, even if that would include bad actors. And on the other hand, you've got people advocating for like government oversight and intrusive surveillance to prevent misuse, among others, even if that would really slow things down. And I think this is a false dichotomy. I think we really can get the best of both worlds if we manage to get the right infrastructure in place, basically. And that's essentially also the reason why I started working on Stromly to basically build this kind of tooling to help the relevant parties in the space coordinate more effectively. And at the moment, this specifically means developing new protocols to help labs screen their generative models for dangerous capabilities like hacking or biorisk. And one specific attempt to do that is through a protocol we call hash marking. So imagine you're interested in measuring capabilities related to a sensitive topic like bioterrorism, say, and your first thought might be, maybe I can just put together a traditional benchmark on this topic and use that when interacting with developers and sourcing that from domain experts to make everything work, and that should solve it. But if you think about it, creating the benchmark is essentially putting together an FAQ with questions and the correct answers to those questions, such that you can use them as reference solutions. And simply publishing an FAQ on a sensitive topic is, again, a bit tricky. So the idea here is that maybe we can treat the correct answers in such a benchmark as a password, where we wouldn't necessarily want to know what the contents of the password are, but we would like to be able to verify that a certain candidate answer provided by a model is the same as the intended one without actually storing the plain text, a correct answer right away. So the way this happens is the correct answers in the benchmark are getting hashed, where hashing is a cryptographic primitive, basically. Sorry. It's a cryptographic primitive that takes in an arbitrary piece of data, in this case, the answers, and outputs just some seemingly unintelligible gibberish, like seemingly random sequence of letters and numbers. And when the developer uses the question to elicit a candidate answer from their model, they can also hash that candidate answer and see whether the results match. Basically, if the model got the answer wrong, the developer doesn't know what the correct answer is. That remains secret. And this can basically be seen as building towards the goal of zero trust model evaluation, which means that somehow getting the relevant parties here, which would be the developer, the auditors, and the experts that have this knowledge, to interact in a way that doesn't require trust, doesn't require the parties to trust each other. So we as auditors, let's say, could approach domain experts without asking them to, just send us the plain text information we could read ourselves that's sensitive. They could directly send us the encrypted version, which allow us to administer the evaluation for the developers without anybody else getting access to that sensitive information right away. So this general direction echoes an idea I meant to mention earlier, which is this North Star of building towards zero trust infrastructure in general. which would involve a constellation of tools, let's say, that enable those parties to interact without having to trust each other. And as I mentioned in the previous office hour, if the parties actually do trust each other and for good reason, that would also be awesome. But from the perspective of building the infrastructure itself, it would make it more reliable if it would also work without this extra benefit, basically. And I'll move on to some other ideas of interesting tools that help those parties interact in interesting ways. And you might notice that I'm changing from a case study to a vignette because this case study is actually about a preprint we previously shared. And I'm now moving to more speculative ideas, and I'll do a rapid fire, basically walk through some interesting ideas in this space that we're just at the beginning in terms of exploring them. And this context is about imagine you're a company developing generative models, and you have competitors. So there are other companies doing the same. And you'd really not want to be left behind. So you really don't want to lag behind the offerings of the other players. Yeah, you'd really want to avoid that. Now, keep this in mind. And another relevant idea that will connect to the first one is basically this problem from cryptography called the millionaires problem, where you and I are millionaires and we are having dinner and we want to determine who has the higher wealth so that that person can pay for dinner without us actually mentioning our numbers, basically. And apparently this is possible. So apparently we can interact in such a way as to determine who has a higher number here. Yeah, and if you try to combine those two things, like the context of default race dynamics between companies working on the models and this being able to determine who is ahead without actually sharing that much detail, you could get something like helping those frontier labs themselves interact among each other and essentially able to learn if there is a competitor that is more than like 10% ahead of them on some specific performance measure. And maybe if you're one of those companies and you see that there is nobody ahead of you, you might be less incentivized to race forward recklessly by default. It would be easier to be cautious, basically, if you know that you're not behind. Yeah, this is another idea, basically. And you might notice a theme where there's a general high-level goal related to governance, and we're trying to approach it with elegant ideas from cryptography and mathematical tools, basically. Another instance of such an idea is what I'll call here neural certificate authorities. And this is directly inspired by certificate authorities in traditional internet infrastructure. So if you're accessing this on Discord or YouTube or wherever you actually access this, there's a padlock in your browser that indicates that the entity you're interacting with, like Discord or YouTube, is actually legit. And that padlock requires a certificate to be issued by a trusted third party. So there's this other third party that has to run some background checks on Discord and YouTube essentially, and issue a certificate that the authority signs afterwards using a digital signature that's really difficult to forge. That's the primitive used here. And in the context of AI safety, I think something like this could be really interesting to help auditors, the organizations running evaluations on various models, be able to publicly display the fact that, yeah, we ran this evaluation on this model and we got this and this result, and then sign this statement basically, so that they can prove that it was, it issue it in a way that can't be forged by other parties basically. And if you have one auditor issuing one certificate containing data about the model, and maybe you have another one who ran an evaluation from a slightly different perspective. Maybe one was focused on cybersecurity capabilities and the other was focused on tendency to deceive or something like that. Maybe you could also have another party, yet another node in this space that says, I see those other trusted parties that said things about the model, and based on their observations, basically, and the fact that I know they're trusted, I can also say something. So I can basically issue another statement at a higher level of abstraction that says, this model seems safe enough for a specific application. And I would also sign my name underneath as the third node in this space. And this could kind of allow a composition of those results, because at the moment, no single auditor has the capacity to cover all the relevant risks. And I mean, even the totality of capacity in this space is not adequate at the moment. So it seems likely to remain the case in the near future that no individual player will single-handedly be able to cover all the relevant risks. And this is an attempt to partly alleviate that. Anyway, moving on to the next whirlwind idea. This one is called latent differential privacy. And differential privacy is a technique that allows someone to gain insight into a data set, let's say, without learning that much about the individual data points. And that sounds really counterintuitive. But the concrete example is I'm trying to determine the mean, just the average age, the average age of 100 people, without being able to know the the individual ages. And what differential privacy does, it essentially adds, it asks the contributors to add noise to the value they submit. So if my value is 23, I can add a random number, and each party can do the same. And if you aggregate over the whole 100 data points, the noise will eventually cancel out for you, and the mean will be pretty close to the true value. But if I look at any specific data point, it will be the true value plus some noise. And because I don't know the noise, I can't determine the true age, basically. But in the case of language models and the kind of models that are really popular today, it's not obvious how you could just add noise to text. Like noising text seems non-trivial to do. And one interesting idea in this direction is to first take a piece of text, or an image for that matter, then obtain an embedding, which is this list of numbers that represents the contents of the initial piece of data, and add noise to this list of numbers, to the actual embedding, add noise similar to how you would noise the previous ages, and then inverse the embedding process. So from this high dimensional list of numbers, you get a text back, and the difference between the original and the resulting text might be proportional to the amount of noise you added when the thing was in embedding form, in numerical form. And if people, like individual users, could actually partially corrupt their data and send it to be used for training in a more seamless way, that could potentially open up the training process, or generally improve the observability of that, in a sense that would also allow better monitoring and related things. The idea with this one is, let's try to make it attractive to open up this training process by having contributors send their own data, so that you can actually, as an auditor, for instance, as a third party, gain insight into what's happening here. But yeah, quite speculative. And I think the last idea in this list is what I'll call cognitive kill switch, which is uh, I'll start differently. So you might know that some of those recent language models have guardrails against being able to provide you illegal information. Say. So if you have a raw model, it might comply with just providing you with a recipe for concocting some sketchy thing. And then you have guardrails that make it more avoidant with those kinds of requests, or at least treat them in some different way. But then you can also, if you have access to the actual weights, the actual model, you can also just fine tune the safeguards, the guardrails away, and obtain a model that's more open to helping you with this kind of stuff. This was recently studied basically. And the question is, what can you do to the initial model such that the guardrails are more difficult to remove? They're stickier somehow. And then an interesting related idea from machine learning, so this one has nothing to do with cryptography, is training a model such that if you then train it a bit further, so if you then fine tune it for a specific task, that second stage works better. Basically, this idea called MAML, just a random, pretty cool, but quite obscure approach from machine learning, where you try to optimize an initial model such that if you then train it a bit more, it quickly gets good performance on a task you care about. But in this case, you might want to do exactly the opposite thing. So something like train the model with guardrails so that it's difficult to remove the guardrails. It's difficult, computationally expensive at least, to fine tune it to do illegal stuff, basically. Or even, or even differently, you could train it such that any further corruption or any attempts to tamper with the model at that point leads to the activations kind of dying out. So the activation is going to zero. And because of how gradient descent works, it might be difficult to optimize the model in that state to whatever towards whatever other goal you have in mind. So those might be some options. Now, they might also make it harder to fine tune models towards beneficial tasks. But I'm generally excited about at least having options with trade-offs and having different options with different trade-offs that allow you to decide on a case-by-case basis. And even if this idea is more of a self-contained intervention that doesn't really help other parties coordinate, I think it could definitely interact with some of the others. For instance, let's say someone issues a certificate attesting that they have included this kind of kill switch in this specific model, or only attests that there is that this specific model contains something like this, has been applied to this kind of mitigation by somebody else. So I think those things could compose in interesting ways, but they're quite speculative at the moment, as you be able to tell. Yeah, this was generally a whirlwind tour of ideas that combine, let's say, mostly cryptographic primitives with real-world goals in related to AI governance, basically. Yeah, and as potential next steps, I'm really encouraging you to hack together some kind of prototype, or even put together a mock-up of sorts of such a piece of infrastructure. It doesn't have to be one of those in the slides. It could be in the same vein. Yeah, you can also join the office hour tomorrow at the same time as the one today, and more generally, feel free to just reach out. And if you're interested in this flavor of projects, feel free to also keep an eye on updates from our pages, basically. Yeah, and I think we have a Q&A now. And
Yes,
I'll
indeed.
keep the slides in this overview setup. Maybe it's easier to refer to things.
Yeah. Thank you so much, Paul. Deserves a little round of applause from everyone's muted locations on the internet. Yeah, that was super inspiring. Really, really good. Very interesting to see these vignettes of different types of potential techniques. Of course, several of them quite experimental, but I think these are things that are exciting for us to look towards the future of where things can go. If anyone has any questions, you are very welcome to just unmute yourselves, and we can discuss your topics. And maybe I'd kick off with one. I'm curious about the cognitive kill switch, the second solution you mentioned, using MAML to basically have the activations go to 0 around the target, like latent space location or wherever you go. I assume that would create like some sort of zero activation mode around safe behavior, which sounds super fun and like quite an interesting solution. How are you thinking about that, and how feasible do you think that is?
Yeah, actually, that's exactly the kind of visualization I had in mind. So the most popular metaphor for thinking about gradient descent is you have this kind of landscape and you're heading towards the global minimum, the lowest point on this landscape by following the slope mostly. But yeah, not as simple as that. And ideally, I think it would be cool to somehow engineer into the parameter space. I think it's the space of potential parameterizations rather than activations. It would be cool to somehow be able to engineer a flat region around point you care about, because following slopes from that point on is would be difficult. Essentially, that's that would be the best case scenario intuition. But I'm sure it's definitely not as simple as that, especially given the huge dimensionality of this space. Like you have as many dimensions as parameters, and now you have billions of parameters, so billions of dimensions. So it's really tricky. The kind of thing I had in mind where if you could do some kind of geoengineering would lead to interesting outcomes.
Missed a little bit, but wonderful. Yeah, I guess it is this geoengineering of the data set as well will be a really hard task. Charlotte, you have a question as well.
Yeah, thank you so much for your talk. I am interested in how did you personally upskill to do this kind of work? How useful is cryptography? What kind of skills should people develop? What kind of university courses to take to work here?
So I personally do not have a formal background in cryptography specifically, or even mathematics generally. I studied AI in uni, which was a mix of courses from different related disciplines. And I think related to this, I think it's very useful to just get a sense of high-level affordances offered by those kinds of primitives. So you have, let me try to give some examples. So the primitives I mentioned here on different slides, let's say hashing, it's a very general high-level concept, and you have a bunch of instances of this. I think looking into specific instances of those primitives is not a great thing to start, not a great place to start at when you're trying to just get a lay of the land. I think that's what could be really impactful, knowing what kind of tools are made available, but by this field. I think this is really powerful because then you encounter problems, like real world situations that could use some help. And then this idea, like, and take out your conceptual toolkit, basically, knowing what kind of things are possible and available, and see whether something like that is possible. That's also why I've described most of those as speculative, because my own understanding of the details of those are limited in the following way. So I tried to get a sense of how simple versions, simple instances of those primitives work, and generally what they try to achieve, but I have no thorough understanding of how the most sophisticated advanced versions of those work. So I think definitely, I think even getting a high level overview of what's made possible, yeah, what those tools enable is really helpful at this stage. Both personal stage as in an upskilling process and stage in the field more generally, where, as I said, the infrastructure in this space is not as mature as we'd like it to be, but I think we have a lot of lessons to learn from domains with more mature infrastructure, like traditional internet infrastructure and similar. This is how I describe the cryptography part specifically, and I would particularly recommend the courses from OpenMind. So OpenMind is this non-profit organization, I think, that advocates for using cryptographic tools in socially beneficial ways, and they have some really high quality online courses that I personally enjoyed. Open mind as in like Minecraft kind of mind. Yeah, exactly. Yeah, I think
Nice.
those are really cool for.
Yeah, I think I'll definitely check them out now that you mention them. Charlotte, do you have more to add or a follow-up? No. All right. Another question that follows from this is you've looked at these primitives from internet and from cryptography. Do you see some other domains, like I could imagine anti-cheat in games or something like this, or yeah, which other domains could you imagine we might want to look at?
Mm-hmm. Mm-hmm. Yeah, that's a really good question. I think, yeah, okay, I'm a bit biased, but I think there's something in the case of cryptography that could show up in other fields, definitely. That's somehow fundamental about our relation with information. So at a really abstract level, it's like this, the science, not the science. Okay, let's say the science of secrecy or something like that. So it seems to be touching on a very fundamental topic that shows up again and again, and especially given that AI is highly digital. And how do I say this? Mm, Yeah, okay, so I'll try to say that I think cryptography specifically seems to touch on something fundamental about information, and information seems to be a crucial element of what's going on with AI. That's my picture of it, and why I was also particularly attracted to just look into this stuff and learn about new tools and techniques that exist. And the very rate so we started strongly like 2 months ago, and we kept looking into those ideas, and the sheer rate those that I think are personally interesting ideas, I think it's crazy high for other fields I've been looking into before. And I think this fertility somehow is also partly due to there not being that much bandwidth between those fields in those specific ways, or advances in cryptography being still relatively recent. So I mentioned a a few things here. This one in particular, like this primitive. Some of them are not computationally tractable yet in many applications. For this one, I just mentioned, okay, let's share a number. Let's work with like individual numbers and run a basic calculation on them. That apparently it's feasible, but they're constantly improving and getting closer to real world applicability. But I forgot where I left with this observation. I just went on an arbitrary tangent.
I guess it was on information theory or information sciences or information security as an alternative to this internet/cryptography domain.
Yeah. So the general reason I was mentioning that I think it's a really fertile space for like, ideas. Basically, that okay, they have to be turned into actual real world tools that can have a real world impact. But I think that's a start. And I would look, for if I were to look in other fields, and look for connections between AI and that other field. I would look for fields that give me the same sense of they seem to touch on something fundamental and it's related to AI in a interesting way. So just field being cool is a big part of you getting to get to those ideas, I think.
Nice, perfect. And Nyasha has a question.
So I think the general promise of zero trust is to make things work even if the various parties don't trust each other. That's like the plain English description of that. And there are more sophisticated primitives from cryptography, even that might be overkill in many situations. So even considering something like blockchain, I think it would get you something like from the first sentence, why are we combining those two technologies right now? It seems like there might be more efficient ways to do things. So I think what I was mostly gesturing at is the general idea of the state of affairs where things can work without parties trusting each other, where trust could be used as like temporary scaffolding until we get there. So until we get like a stable version of this whole infrastructure thing, I think trust can be useful for basically like glue between the various pieces and making everything work. Even in, for instance, here, I mentioned there's a third party doing something, writing off this digital signature. That third party needs to be trusted. Like it's still, even in the case of internet infrastructure, this still works by trust. So you need to have like the Google certificate authority or something issue a certificate. It's not only big name certificate authorities, but it's still, this one still works based on trust. I'm not sure if you're looking for more specific ideas of applications. Like it seems to me it would be a desirable property of many individual pieces of infrastructure rather than an application itself.
Yeah, and I guess it's also much more attractive
anyway.
to companies compared to them having to have intrusive oversight, as you mentioned earlier.
Yeah, I mean, with certificate authorities, you also have entities like Let's Encrypt, who I think are issuing certificates for free after they run some background checks. But having a certificate issued for you could cost money. So I get that it could also be the cynical explanation here, but I also tend to think that we simply don't have a better solution at the moment than this one that in one specific place involves trust, like having this third party. Otherwise, there's a whole back and forth as seen in this random diagram. It's more reliable, but yeah. Yeah, I agree with Charlotte in the message. I think those are really cool resources.
Nice.
Actually, I think there's in the Blue Dot AI governance course, there's one resource which is something like a brief tour of cryptography tools or something like that, in which I think also contains a very cool high-level summary of what's made available by those. Let me try to find it. But maybe I can stop sharing my screen.
Nice. I also see one of the Open Mind courses. It's 60 hours. So that's good. That's enough to grab hold of at least. Are there any other questions while looking through?
Yeah, I have a question. If I understand correctly, Stromly is working on some of these governance tooling solutions, right? I have a bit of an echo. I think I would be interested in understanding how, like, which of these solutions you see as like amenable to being tackled by small startups, and which others might not be suitable and need other players to tackle it, and how you personally make like the call on what is worth your development time versus what is maybe just not the right fit.
Yeah, I think that's a great question. We also thought a bit about how to best structure this entity. I think there are interesting precedents of organizations, slightly different types, working on public goods kind of infrastructure, including like things related to World Wide Web, like hugely influential standards for how the internet works, for instance. This is, as you can see, a place where we get a lot of inspiration from. I think, yeah, that's definitely one point. Like various types of projects would fit better with different types of entities. Yeah, and I'm also coming from a background of working based on grant and the grant on specific research projects. And with this, I was attracted by the prospect of potentially making this more commercially sustainable and potentially using productizing research as a way to also scale research in interesting directions, including this general direction. So to try to give some specific examples from the ones I mentioned. So the hash marks one, the one I mentioned at the beginning, that's the most mature out of the list I presented, is something we essentially use today. So we currently have this web console through which we allow you to basically add models, register models, and then launch evaluations on them. So we currently play primarily the role of an auditor, even if we're secretly interested in the infrastructure underlying the interactions between like auditors, developers, experts, regulators, and so on. So we are using the hashmart idea for a concrete evaluation called Biowarfare 101, where we currently have like a dozen questions with the hashed answers. So it feels also better for us to know that our machines haven't touched the plain text answers. So we ask contributors to send just the obfuscated versions, and after we run a sanity check, just delete the previous version. Yeah, so this is an example of how we're actually applying one of those things. I think I could see how it could be applied in a pretty straightforward way was that intervention at the end where you have a model and you have this specific mitigation where you try to make the guardrails more sticky. I could see how that could be offered as a self-contained patch to basically get you better results on an evaluation if, let's say, the evaluation is very similar to that on RLHF paper where it essentially tries to simulate a bad actor trying to fine tune the guardrails away, and you see that, oh, actually it's not that easy. So the intervention and the evaluation can be offered as complementary things. Yeah, and maybe a final example that's a bit trickier. Maybe the one for connecting the big players, allowing them to talk with each other so that maybe they have less of an incentive to just race ahead. I could also see us offering the actual tooling, like the actual software you use to run this kind of communication between the closed group, to make the interaction possible. So I think part of those tools are, yeah, we could essentially commercialize them in a pretty straightforward way, or rather offer services related to more the convenience of not having to implement actual software that relies on this coordination protocol yourself, or yeah, a mix of that. Although I definitely agree that there are pros and cons for various types of organizations. Like, yeah, does that generally make sense?
Yes.
Yeah,
Yeah,
like
that makes a lot of sense. Thank
yeah.
you.
So, yeah, also being able to prove properties about those models rather than just trusting some other party that they ran a specific evaluation and they signed their name underneath. And that's also a really cool direction. It's just that I get the sense that it's still relatively far away from being computationally tractable for, okay, at least the naive things you might try to think about, like obtaining zero knowledge proofs involving like a ginormous model in some way. There might be like cunning ways around just combining those things, like moving a bit around the what seem like constraints in making this work. But I agree, like even I remember, I think the first interesting provable guarantee in like adversarial robustness was, okay, there were all those kinds of attacks where you can add some small perturbations to an image and you would get the classifier to mess up. And there was this interesting paper that proved that so they trained a specific classifier using a technique, and they proved that there exists no perturbed image in this range. So if you add this amount of noise, the guarantee on that not messing up the classifier more than this amount or something like that. So yeah, that's also really cool. Yeah, I think they're complementary, let's say. Yeah, I think the main obstacle there is making things computationally tractable in some domains, although yeah, I still don't think no, I'll take that back. It might be the case. Yeah.
Wonderful. All right, if we have a last question, then let that be that. So yeah, I think we also had
So
we
yeah,
had
sorry.
a verifiability, like a neural verifiability hackathon too. And I think Siku Coulter, one of the big researchers in it, has now moved over to more of this, or I guess jailbreaking work or adversarial example work instead, because it was just, even if verifiability on neural networks improves year by year a lot, then capability and the compute sizes just increases way too much. So the sales pitch to companies to have verifiable neural networks was like a bit bad.
Related to the final question, it's a paper on that is actually a work in progress, but it's not published yet. If you want, I can send you the overlift link if you want to leave some comments or something like that. That would be cool.